There are a million different ways. That's an exaggeration, of course, but there's a bunch of different ways that you can factor that have been developed for the situation where you have a number in front of your x squared term. And I have taught a bunch of different ways. You can do the box method, you can do trial and error, you can do factor by grouping, and to be honest, this one I'm going to just try this for me for at least one problem. If you have a different method that you want to use, I will be happy to help you if you like the box method or if you like a different method, learned it a different way. I actually had a student teach this to me in the resource room, and I have ever since I learned it, I have never switched back, because this is the easiest way I have ever seen to do factoring with a number in front of the x squared. It's called the Berry method. It's not, I've never seen it in a textbook. I have seen it online because I've looked it up, and we did a proof for it and everything to make sure, because it will always work. But it's not a typical method that's taught. So if you're looking at the Delta Math, the setup for that might give you a different thing, or if we did a Math Excel, it might give you a different way. But I promise, just try this and see if you like it, because this is the easiest way I have ever learned to factor these questions. So it actually works, and you could use this with the questions that we did yesterday. It just wouldn't have one of the steps, but it works the same way as what I was working with for you guys yesterday. The main difference is you'll actually have an A value. So you're going to multiply, find two numbers, you're going to multiply A times C. So the first coefficient of your quadratic term and your constant term, we're going to multiply those two numbers together. So it's going to be two numbers multiplied to give you that value, and it's the same as yesterday. They're going to add to give you the B value. So like I said, the main difference, our A value for all those questions yesterday was 1. So it just looked like we were doing the constant. So we're just going to multiply first and last. So I'm going to do 2 times -4. So that would be -8. And I'm always going to add to get the linear terms coefficient, which is -7. Okay, now while we're thinking about that for just 1 second, I'm going to set up my two little sets of parentheses. So yesterday we started each of the terms with just an x and an x. What I'm going to have you guys do today that's just slightly different, actually really it's not, we just didn't tell it to you yesterday. You're going to take the first term, whatever that is 2x squared, copy that, but don't put the squared. So I'm going to put 2x at the beginning of each of these factors. All right, so we're just going to take that first term, just drop the squared, and put that at the beginning of each of the factors. That's what we did yesterday too, right? We just did x and x because it was x squared, so it's the same process. Now, we're going to fill those factors in with the two numbers that fit both of those requirements. And there's only two numbers that will fit both. Multiply to give me -8, same two numbers, add to get me -7. Can anybody think of the two numbers that would fit both of those requirements? Multiply to get -8, add to get -7? Yes. Wait, say that one more time. So close. Yes. Okay, so we're going to use 1 and -8. That'll multiply to get me -8. 1 plus a -8 will give you the -7. You don't have to write that down. That's what we're going to put in here. Okay, so make one of these a -8 and one of these a +1. Okay, now, this is not the correct answer. If we were doing what we were doing yesterday, we'd be done, we'd stop, we'd just move on to the next question. If I were to FOIL this back out, right, 2x times 2x is not 2x squared, it's 4x squared. So one, or in some cases you'll run into this, both of these are not the real factor. Here is how you can fix it to make the problem work for you. So, inside your parentheses, just look, I just wrote 2x minus 8 first. If those two terms have something in common, that is not the real factor. So, this is not the real factor because 2x and 8 are both divisible by what? 2. Okay, now, you do not pull that out in front or anything like that. It's literally just like reducing a fraction. You're just going to divide both of those by 2. The real factor in our answer would just be a plain x minus 4. That would be a real answer. And the other factor I wrote down, 2x plus 1, the 2x and the 1 don't have anything in common, so that actually is the real factor. And this should be your answer. Now, especially on these questions where I have the number in front of the x squared, I try to tell people, like, just take a second and spot check this really quickly. If you multiply, you don't have to totally FOIL this out, but if you multiply the two first terms together, just like we were going to do a complete FOIL, but I'm not going to do that. If you multiply the two first terms together, it should give you the first term in the quadratic. So I just check it that way. X times 2x, yes, that's 2x squared. That should be good. And then if you take the last two terms, the two constant terms, they're -4 and 1. If I multiply those together, that should give me the last term, which is -4 times 1 is -4. So I should be okay. So I just kind of spot check all these problems just real quick before I'm done. If you want to completely FOIL it out to check, you could totally do that. But I would at least take like 1 second, check the first two, make sure it gives you the first term, and check the last two, make sure it gives you the last term in the original problem, and you should be good. And all that's over here on the side is just kind of explaining what I just did with you guys, just so if you wanted to go back and look at it, it would show you the process and you can read through that. But that's what we just walked through. Is anybody having a question? Okay, now I know this is weird, so we're just going to practice some of these. These are all just like a random mix of different quadratics that you can factor where there's a number in front of the x squared. All right, so for part B, I've got 5x squared minus 23x minus 10. So multiply a times c. So we're going to do first times last. 5 times -10 would be -50. And I want to add to get -23. So just as I'm kind of thinking about that, let me set up my two little sets of parentheses here. And again, just take the very first term, which is 5x squared here. I'm just going to drop the squared, and I'm going to write 5x at the beginning of each of the factors. And then we're just going to fill those in with the two numbers that match, multiply to get -50, the same two numbers add to get -23. Anybody know two numbers that would fit both of those requirements? Ethan, what do you think? Yes. Okay, so just make one of them a -25, make one of them a +2. -25 times 2, that's -50. -25 plus 2 adds to give you the -23. Okay, now, this is not the answer, because if I actually sat there to FOIL this, this would not give me what I have above there. So, to get the real factors, just look, if any of the terms have something in common in the same parenthesis, we're just going to get rid of that. So, do 5x and 25 have anything in common? What do 5x and 25 both have in common? What do you think? 5. Okay, what's my real factor going to be? Perfect, just x minus 5. Now, the other one I wrote down, 5x and 2, that doesn't have anything in common. So that is the real factor, and then this should be my answer. And just as, like I said, just a quick spot check. Just if you take the two first terms and multiply them together, x times 5x, that should give you that first term, which is 5x squared. We're good to go. And then just check the last two real quick. That should give you the last term. -5 times 2 is -10. You should be totally fine there. Just to make sure that that would FOIL back to give me the original problem. So this is the factored form. The question was given to us in standard form. All right, right next to this, a times c. So I'm going to multiply first and last. 9 times 4 is 36. And I'm going to add to get the lovely number in the middle attached to the x, which is 12. And as I'm maybe thinking about those a little bit, I'm just going to start out and I'm going to write 9x at the start of each of my factors. So it's just that very first term. Just drop the squared at the beginning of each of your two factors. And we're going to fill it in with two numbers that multiply to get 36, the same two numbers that would add to get 12. Can we think of two numbers that fit both of those? Rudy, what do you think? 9 and 3 would multiply to give us 27. They would add to get 12 for sure. Okay, if you're not sure, and 36 is a little bit tricky because it's got a lot of factors, but you got 1 and 36, 2 and 18, 3 and 12, let's see, 4 and 9, and what else do we have? 6 and 6. There you go. See, and sometimes if you just write it out, it'll come to you real quick. All right, so plus 6 plus 6. Now, not the right answer, right? 9x times 9x is 81x squared. That's totally wrong. However, both of these factors, this is kind of weird, both of these factors are identical. What do 9x and 6 have in common? 3. All right, so neither one of these is the correct factor. So this does not come out in front, nothing like that. We're literally just going to disappear out that 3. So the real factor here, if I divide both of those terms by 3, 3x plus 2, this would be identical, 3x plus 2. And I'm just going to do a little spot check here. So first term multiplied together in each should give me the first term, which it totally does. 3x times 3x is 9x squared. Last term in each multiplied together should give me the last term in the original. 2 times 2 is 4, we're good to go. The only other thing I would have you do here, since these two factors are identical, let's just squish it together for our final answer, and we'll write it as 3x squared. And you guys will definitely see when we start using this to solve some equations, if you are able to write your factors and they're both the same in that format, that can make the problem really easy to solve. But we'll do that a little bit later in the week. Is anybody having a question at the moment? Okay, so what do I have here? We're going to multiply first and last. So 4 and 18, I'm going to multiply that together, and that's going to give me 72, which is also a number that has a bunch of factors. And we're going to add to get the number in the middle, which is negative 27. Okay, this one I struggled with a little bit, but I'm going to start both of my factors. We're just going to put up our little sets of parentheses here, and we're going to drop the squared and just write that as the first term in each. So this one was 4x squared, so I'm going to write a 4x in front of each. Okay, factors of 72. So always 1 in the number, 1 and 72, 2 and 36, let's see, 3 and 24, and that one I could get to work. To multiply to get a positive number and add to get a negative number, both of the factors have to be negative. So if I do negative 3 and negative 24, that will multiply to give me the positive 72, but add to get me the negative 27. Now, you have to remember, this is not the correct answer. If you FOIL that out, that will not give you what you have written above there. So just look at the factors wherever you wrote them. I wrote the 4x minus 3 first, nothing in common, so that's the real factor. What do 4x and 24 have anything in common? 4. All right, so this one's not the real factor. I do have the first one I wrote down, the 4x minus 3. We're good to go on that. What would the 4x minus 24, what would the real factor be there? Rudy, what do you think?
X minus 6.
Perfect. All right, now these are different, so we're not going to squish them together or anything, but let me just spot check real quick. So 4x times x, first and first should give you the first term, which it does, 4x squared. And then I'm just going to check the last two. Negative 3 times negative 6 is positive 18. If you want to totally FOIL it out, you can, but we should be okay if you just spot check at least the first and last. And I got one more, and then we'll do a couple harder ones on the back. So multiply first and last. So 6 times negative 3 is negative 18. And I want to add to get 7. So to start out my little sets of parentheses, I'm just going to take that first term, which is 6x squared, and drop the squared. And I'm going to write down a 6x in front of both of these terms. And we're going to fill it in with the two numbers that fit the requirements, that they multiply to get negative 18, but add to get 7. If you have to multiply to get a negative number, one value has to be positive and one value has to be negative. I want to add up to positive 7. Can anybody think of those two numbers? Multiply to get negative 18, but add to get positive 7? Ethan, what do you think? Perfect. It's got to be a positive 9 and a negative 2. Now, this one is actually, I think, really tricky. So 6x and 9, that's not the real factor because both of those are divisible by 3. The 6x minus 2 is also not the real factor because both of those are divisible by 2. You do not pull these numbers out in front or anything like that. It's literally just like reducing that down. So the real factor for that first one I wrote should be, divide both by 3. So it'd be 2x plus 3. The real factor, this one is, I think, really tricky. So 6x divided by 2 is 3x. Negative 2 divided by 2 does not totally cancel out. Any number divided by itself is 1, so this should be minus 1. And then to do my little spot check here, Just take the first two, so 2x and 3x. Guess what? We're good. That's 6x squared. And 3 times -1. The last term of each should give you the last term in the original problem, which is -3. So as long as those match up, you should be good. Is anybody having a question? Okay, now there's 2 on the, you don't need all this space. Don't think that these problems are going to take up all this space. It's not like that. It's very important though, you did not see this on any question on the front. If the terms within the original problem all have something in common, so they all have a greatest common factor, you have to take that out first before you try to do the factoring process that we've been going through today. If it has the greatest common factor, you can't use what I just did unless you take the greatest common factor out first. So like if I did this problem, if I did like factors of 240 that add up to 32, you might not be able to even find a combination that would work, but if you did, the factors would not be correct. So all these guys, I got 24, 32, and 10. All these do have a greatest common factor. Does anybody know what it is? All those terms are divisible by what? 2. Okay, so you do need to take the 2 out in front. That would be part of our answer. What would be left over if I took a 2 out of each of those terms and pulled out that greatest common factor? Like what would be left? What do we think? Hunter, you tell me. Perfect. 12x squared, 16x, 5. And I would just look at that real quick too. Like, do 12, 16, and 5 have anything in common? Just to make sure you got out the greatest common factor. We should be good there. Those 3 terms do not have anything in common. Okay, so we're just going to leave the 2 out in front. And I'm going to factor that lovely little set of parentheses just like we did on the front. So just kind of ignore the 2 for a second. I'm going to take the first term of the quadratic in this little parentheses, which is 12x squared, and I'm going to drop the squared. So I'm going to write 12x at the beginning of each of these factors. Now, I am literally just putting the 2 out in front, so I'm just focusing on that quadratic. So here, I'm going to multiply first and last of the quadratic, the coefficient and the constant. So 12 times 5 is 60. And then I want to add to get the b value, the linear terms coefficient, which is 16. Can anybody think of 2 numbers when you multiply them, you'd get 60, the same 2 numbers, you'd add them, and it would be 16? 6 and 10, yes? Okay, so put one of them's a plus 6, and one of them's a plus 10. Now, this is a situation, neither one of these is the correct factor. All right, so 12x and 6 are both divisible by 3, but bigger than 3. Both of those guys are divisible by 6. Take out the biggest number you can. If you start to take that out and you could reduce it down further, do that. All right, 12 and 10 are both divisible by just 2. So keep that 2 out in front, that greatest common factor we took out originally in the problem. Now, the real factor for the first one I jotted down, both of those divided by 6, it'd be 2x plus 1. And the real factor for that second, I wrote 12x plus 10. The real factor there should be 6x plus 5. Now, I'm just looking at the quadratic to check this real quick. So first and last, or first and first should give me the first term. So 2x, 6x multiplied together, that is 12x squared. And then last and last, 1 times 5 is 5. So we should be totally fine. It's just when you write the answer here, if it had a greatest common factor in the original problem, you'll just have that out in front. So I'll have a little 2 out in front of the factors that we further broke down. Anytime you see the word completely or completely factor in the directions, it's trying to imply to you there's some kind of greatest common factor between the terms before you start. Okay, now my very last question today. So I'm going to look at 21, 36, and 12. Are all those numbers divisible by anything? Can you think of a number that would go into all those terms? Hunter, what do you think? 3. Okay, now, can anybody tell me, if you're looking at this problem, this is tricky, so they've got negative 21x squared minus 36 plus 12. What should I factor out of this? What do you think? take out a negative 3. Okay, it doesn't matter about the other terms, but whatever your quadratic term is, the x squared, you want that to be positive. So if they present that to you, like here it's negative 21, you want to actually get rid of the negative, because the factoring little methods I've showed you guys won't work if that's a negative number. So we're going to take out a negative 3. All that's going to do, if it's divisible by 3, it's divisible by negative 3. You're just going to change some signs here. So if I take out a negative 3, left over, this first term would become positive 7x squared. Negative 36 divided by negative 3 will be positive 12, and that has an x with it. And then positive 12 divided by negative 3 would change that sign up, so that's going to be a negative 4. Now, I'm going to leave the lovely negative 3 in front, and we're going to factor the quadratic that's in the parentheses. So I'm just, here, Tyler, I chose a bad color to use on this, but we're just going to focus on this quadratic here. So I'm going to multiply first and last. So we're going to multiply 7 times negative 4, so negative 28. And I'm going to add to get the number in the middle, which is 12. And I'll just start out my lovely little parentheses with the first term, which is 7x, just drop the squared. All right, now, factors of 28, let's see, we got 1 and 28, we got 2 and 14, and we've got 4 and 7. So how can I get a combination there to add up, multiply to negative 28, but add up to positive 12? I'm going to multiply to get negative 28, add to 12. Can't everybody think? Heck yeah. All right, one's a positive 14, one's a negative 2. That'll multiply, give you negative 28. 14 plus the negative 2 is going to give you that 12. One or both of these factors is not the real factor. In this case, it's just one of them. It's just wherever you put the 7x plus 14, both of those guys are divisible by 7. So we're just disappearing that out. My actual answer to this lovely question, you do need that greatest common factor that we pulled out in front, that negative 3. One of the factors should just be x plus 2. The other one, the 7x minus 2, that was the real factor because those don't have anything in common. And again, just real quick, as a favor, just spot check this. So if you multiply the two first terms together, x times 7x, that should give you that first term there, which is 7x squared. The last two, positive 2 times negative 2, should give you the last term in that quadratic, which is negative 4. So just take a second and just spot check those, because I always know these problems are kind of tricky. If you want to completely FOIL it out, really that is another way you could check. I'm just trying to save you guys some time. But this should multiply back together to give us the original problem. Is anybody having a question?